Good evening. Today we are going to learn about analog electronics, and I'm your presenter by the name Manuel Kelvin. You are welcome. Today our lesson outline will include 6 items. That's one. The first one is voltage and energy, then basic principles. We shall look at Ohm's laws. Then we shall look at resistors, both in parallel and in series. I'll give you a few equations, and I'll give you questions later so that you're able to go and then analyze more on the concepts and do practice questions on the essays. I mean on the equations that I'll give you. I'll go straight to the first concept, that's voltage and energy. In this case, I'll just give definitions and units and symbols for the units of the two concepts. The first concept that I'll define is called energy. What's energy? Energy is the ability to do work. Energy is measured in joules, and the symbol for joules is capital J. Other units for measuring energy include calories, kilowatts, milliwatts, among others. On the other hand, what is voltage? Voltage is the work done per unit charge. Is given by joules per coulomb. In other words, it's the work done per unit charge against static electric field to move charge between 2 points. Also, 1 volt, which is the unit of measuring 1 voltage, is the electric potential difference between 2 points that will impact 1 joule of energy per coulomb of charge that passes through it. That is it. There's an equation here that relates voltage and charge and energy. In other words, for us to get energy, we have to multiply voltage and charges. When you multiply voltage and charge, you get what? You get energy. Now, I'll go to the next concept, which is the basic principles. In this case, we look at what electromagnetism is, how do we get EMF, how do we get voltage between 2 points. Electromagnetism, this is the voltage is a unit of either electrical potential or EMF. EMF is electromotive force. In electronics, including the text, the term voltage refers to the physical quantity of either potential or EMF. Note that we will use SI unit, as does the text. As usual, the sign convention for current is capital I, which is given by change in charge over change in time. That is, I is the positive in the direction which positive electron charges flow. We'll begin by considering DC current, that's direct current, where voltage and currents increase in the positive direction. In this case, Ohm's law and Kirchhoff's law, we'll soon see how this generalizes to AC. Therefore, what we mean here is that we are starting with DC, which is direct current, and AC, then later on we shall move to AC, which is alternating current. We are starting with DC current because this is easier to understand and is more direct other than the AC current, because in AC current we shall reduce transients, we shall reduce real-time changes in voltage and current, and it will be a bit complex. That will maybe we shall be covering it in the next maybe 4 or 5 lessons after we have had very basic concepts on and we understood well about the DC. Now I'll briefly talk about the Ohm's law. What's Ohm's law? Ohm's law is the relationship between resistance, current, and voltage through a given circuit. In this case, we say there's a figure here I've shown. There's a resistance. A resistance is basically the opposition to the flow of current between a point A and B. How do you define the voltage? I mean the Ohm's law. The Ohm's law in this case shall be given by what? In symbol terms or in an equation, voltage is given by current times resistance. That's the basic simplification of Ohm's law in equation format. Now, with that basic concept, we have resistances arranged in different manners. We can have resistors arranged in series. In this case, you shall add the first resistance to the second resistance up to the nth resistance. We get the total resistance. On the other hand, when resistors are connected in parallel, we get the reciprocal of each resistor. Then we add together and we find the reciprocal of the total reciprocal of the resistors, and then we get the inverse. That's how we get the resistors in parallel. And that makes the end of the first part of our lecture today. I'll give you a short break, then we shall come back and continue with the other part. Thank you.